Okay, we are in the last activity of LSP 121. You guys have done a lot of work in this class. This one is, you make sure you watch the PowerPoints first and it'll make it a lot easier. So let's talk about activity 18, compression and encryption. I have the assignment pulled up here, so that's what I'm recording. Okay, compression is something that's done all the time. And the point of compression is that you don't have to send all the data because it would be, you want to send less data because first of all, there's less chance of a mistake and it also takes less time. So it's used in all kinds of applications. It's a big business. It's a lot of stuff in school if you want to learn about compression. There are a lot of algorithms for it. There's lossy and there's lossless compression. So the lossy stuff is that when you use your algorithm and you send it over, but when they put it back together, it's not all the information. It's enough to show what you want, but it's not everything you want. And then there's the the lossless, which means it's exactly what it was when it was before it was sent. Now, we talked about this on the PowerPoints. This has to do with run length compression, where we talked about how you have to, and actually we used the first part of this. So what you do is you find the runs. This only works if you have long runs of ones or long runs of zeros. So here we have 5 zeros, so we put the 5. Then we have a 1. So what we know is because we decide to separate these two runs out, that there's 1 in between them. Otherwise, we'd have 14. So then we have 9. Then we have the 2 ones. There's 0 runs of zeros between them. So we have 0. Then 15 zeros. Then another 1, followed by 4 zeros. And again, the break in these two numbers, instead of having 19, we have 15 and 4, means there's a 1 here. Another set of 2 ones. Another set of 2 ones, followed by 20 zeros, and then followed by a run of 6. Okay, so here's what we've got. We've done this already, so what we do is we have the run data, we convert those into nibbles. There's our nibbles. I love that. And that's what we have. Okay, so what are the decimal runs of zeros for the following binary string? So we counted, so was there 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 9. And then we'd have to split it at the 1, but we know there's going to be a 1 between them. So then we have 1, 2, 3, 4, 5. Then we have 2 ones together, so we have to put a 0. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And remember, if it was greater than 15, we probably have a problem. And if it's greater than 15 over here, which it looks like it is, I'm not dealing with it. Then we have another 1. So we know that's going to be there because we're going to split these two. 1, 2, 3, 4, 5, 6, 7. 7 followed by another 1. And I'm guessing there's probably 20 in here. So let's just stop there. Normally, I guess what we would do here is we'd have to put, we'd have to create the two nibbles for this. So if there were 20 here, we'd have to do the full amount, which would be the 1, 1, 1, 1. And then let's say there were 5 left, I say 0, 1, 0, 1. And I would know because this is full amount, I would have to have some algorithm that would say these are together. And then we have another 0, and then we have, because those 2 ones are there, then we have 1, 2, 3, 4, 5. This would be 20. And then we'd have 0, then we'd have 5, and then that last guy. Okay, and then we'd have to translate these into nibbles. So you just find the corresponding value and then calculate what the reduction is. How much did you send versus, so this would be how much did you send versus the size of the original message. Okay, so let's talk about encryption. This is our last subject. We have substitution-based ciphers, and that's what we already talked about. So here's an example. This is our plain text, the numbers, the letters we would substitute instead. And if we were to encode how about lunch, we would say, okay, how is H is E, then we look for O is G, W is V, etc. Then they broke it into groups of 4 and 5, actually 5, so that you can't really see patterns in it. Okay, so using the plain text and corresponding ciphertext and code the message, this is cool. So we would go to the top line, look for T, which is M, H, which is E, I, which is W, S, which is A, and then we have I, which is W, S is A, and then C is I. Let's see here. I think I have my fingers on the wrong keys. Let's try this again. Okay, this is T is M, H is E, I is W, S is A. Now I think it was right. I again is W, S is A, C is I, O is G, G, and then we have L is K. Okay, so this would translate into this is cool. Then there's the transposition ones, which are kind of neat. So what you do is you pick, so in this case, in the example we use White Sox in our PowerPoints. In our activity, we're using the word computer. So we take the word computer, then we sort those letters. So the first letter in the alphabet that appears in the alphabet in the word computer is C. The second is E. Then the third is M. The fourth is O. The fifth is P. So we sort this out and then assign your numbers. Then what we do is, like we did in the other example, list out all our positions, and then we write out the string underneath it. So this has 6 letters in it, so we every 6 letter, then we go to the next line, and then we pick the first column and write it down, right? So it's TEBSV, and then you go to the second, and it's TLEE, and then to the third is IEIR, etc., etc. And that's the message. That's how the message is encoded. Okay, it's really it's really important what you choose as a keyword. So in this word, we have the keyword racket. I'm going to put a table in here. It makes it a lot easier. So let's insert a table. And it's the word racket, R-A-C-Q-U-E-T. And then we go down. Let's see. I want an ice cream leaf word. Let's just throw in a bunch of columns in here. And so it's going to be R-A-C-Q-U-E-T. And I want to sort this. See if it'll let me sort it. It'll be under there. There it is. Won't let me do. I have to do it by the whole column. Okay. Okay, let's sort this guy. Okay, so A is 1, C is 2, E is 3, Q is 4, R is 5, T is 6, and U is 7. All right, and then we would say I want an ice cream. Why couldn't it be a shorter one? Cone to eat before I eat my dinner. All right. And then what we do is we go to the first column and we say A, W, C, C, whoops, not A, W, C, C, A, E, D. Do not include the first letter in there because you don't want the word racket. We don't want them to figure it out. Okay, so then we go to the second column, which would be A, E, O, T, I, I. Third column, A, E, T, F, T, E. Fourth column, NCNBEN. Fifth column, IIMERY. Sixth column, TNAOOMR. And seventh column, UTREEAN. And that would be how we would encode that message. Okay. Then what we'd have to do is, well, then we'd have to get the ASCII values for these and go on from there. So that's our encoded message. And then those 6 questions, one of the most important forms, common forms of communications, email, used for everyday conversations. Do you know how to send encrypted mail? That you'd have to look up yourself based on what email you use. And I believe that's everything that we have for this activity. I hope you enjoy it. Make sure you put it in the Dropbox. If you have any questions, please email. And I hope you enjoyed this last activity.